Broadly speaking, across my research, what I aim to do is fundamentally understand what it is about stories that allow them to achieve these really engaging, educational, entertaining effects using computational modeling and simulation as kind of the way that I go about exploring these research questions.
I'm working in the field of natural language processing, which is a branch of computer science that deals with building models to analyze and understand large amounts of text.
So I'm currently working on techniques to sort of bridge the gaps between open source software security, bug detection and threat assessment, and closed source and sort of complex software and system bug detection.
I'm currently working in the Master of Software Development, which is a 16-month intensive program producing capable developers, big data analytics, and computer security experts.
So I'm currently working on computational and mechanical systems in surgical robotics.
I'm currently working on human-robot interaction and human-AI alignment in general.
I'm currently working on computer security and software security.
I'm currently working on looking at web browsers and making them faster.
My main field of research is computer vision and AI, where I create models to enable machines to see and understand visual inputs like images and videos.
So currently I'm working on advancing the theory and practice of resource-efficient data structures.
So I work in the field of crisis informatics, where we study how people make sense of the information in online environments in the crisis situations.
So I'm currently working on working with people who have just had a spinal cord injury and finding ways to help them better control the space around them.
I'm currently researching how students learn computer science, and specifically, how can we help them think about other people at all stages of implementation.
So the biggest challenges that I think are facing human-centered computing, which is the broad area that I work in, are related to the sort of different ways that people interact with technology. This is really difficult to accommodate because we can't use our traditional methods to just sort of probe what is it that you do or that I do, because everyone does something different and we can't talk to everyone.
So to me, the major challenge is how to create abstract mathematical models for real-world problems.
So we have really great algorithms that can teach simulated robots to do really complex, fun tasks on the computer, but as soon as we bring these things into the real world, all of a sudden the robot has to deal with different lighting conditions, different object properties, and really being able to generalize from sim to real is a hard problem in robotics.
But a big challenge is making that transition from the lab out into the real world, because that's the only way that we can actually have an impact on people's lives.
One of the main challenges in my area is how do we teach students to think about ethics in a meaningful way within computer science? I think ethics is something that instructors and students are thinking about broadly, but it's not always clear how big ideas about ethics or big scandals that they read about in the newspaper might affect what they're learning about on their homework.
One thing we're thinking a lot about is making sure that as we grow, anybody who's interested in computing can succeed in the major, and this means making sure that even people who might not see a bunch of people who look like themselves in the field can still feel like they're in the right place and they're welcome and they belong.
This one is fun. I like this question. I think the my prediction for computing is just going to get even broader, right? The computing field keeps growing in the sense that there's so many applications in so many different domains, and I think in 10 years, in addition to fintech and digital journalism and bioinformatics and all these other fields that already incorporate computing, there's going to be even more.
I think in the nearest future we will be able to build systems which are fully verified, essentially come with a mathematical proof about their correctness. That will be great because it means that we will be able to build software which is bug-free and resilient to exploitation.
I think one major trend, obviously, is artificial intelligence. People have saying it's really influence the world. It's not just some bubble, some buzzwords.
But what I hope at least will change is that every company that is working on AI and developing these models must have safety as their first principle, and that they are not allowed to exist if they don't have it. So that's only possible if we have better regulation and better accountability. So that's my hope for the next 10 years.
I would like us to move in computing toward developing technology that lets us imagine, create more just and equitable futures than the ones that currently exist in our society.
I think first it is like world famous place to study computer science and also artificial intelligence. It's kind of like birthplace of computational graphics. But also when I came here, like I found that it's so kind of friendly environment between both like colleagues, I mean the faculty members, and also students.
In this department, people value my contributions, value interdisciplinary work, and it's just a really, really friendly place to be.
So I chose the Kahlert School of Computing because I was really impressed with the collaborative nature of all the research going on, the fantastic faculty across a wide range of different areas, and just, yeah, a really nice atmosphere and also a great location right here nestled in the mountains.
I'm really outdoorsy. I like to be in the mountains as much as possible, and this place actually gave a possibility that you can do research in the morning, teach a class or a lecture in the afternoon, and then go for a big hike in the afternoon. And that is the kind of work-life balance I want in my life.